Alright, asikhulume nganango question 3. The question 3 it's all about the mechanics, motion in one dimension, or velocity time graphs, position versus time graphs, acceleration versus time graphs. Now, in the description box, there's a links for other recordings for the question paper lena. Thanks for tuning in. Thanks for watching, guys. So now spendule on question 3. What do the engineers at a car company conduct various tests on their cars? During one of the tests, they measure the change in position equal time intervals. The results obtained are recorded in the table below. Voila. So maybe let's say about to design a car, a new car model, Leo company yabo. Then amalokaji mhlambe lama engineers bafuna ukumeasure or ukustudisha the speed ukuthi mhlambe I traveler like bafuna ukunderstand ukuthi I speed saleyo moto angisho yabona imoto ine maximum speed, so bafuna ukubona ukuthi mhlambe leyo maximum speed le moto abaceda ukuyidesign iyakhona ukureach the maximum speed, yes or no. So I think maybe that's the whole purpose for this experiment. Now lagu 2.1, give the correct 3.1 give the correct term of change of position per unit time. Change of position per unit time sounds familiar, right? Velocity. For speed, it's the change in distance per unit time. So learn to differentiate between the two. Velocity is a calculator using iloganji, displacement. Speed is a calculator using it distance. So the change in position basically basitshela displacement la. So kulama questions afana nalawo, mechanics know how to define abu velocity, acceleration, displacement as well, abu acceleration, so yeah. Now lagu 3.1 our answer is velocity. 3.2.1, but for this test write down the independent variable. The independent variable. So the independent variable, Anna, it's what? It's time. And then 3.2.2, the dependent variable. So the independent variable, it's a variable we control. Is control the right word? Or I think it's the variable it's the variable ongana much control give. And then dependent variable, it's the variable it depend on what happened. It's sort of like maybe singati okay. Look, dependent variable singati the variable which changes maybe as a result of independent variable manipulation. For instance, she conducted the experiment maybe for 1 second, from 0 to 1 second. This is independent, right? I'm not much control of this variable. And then kuba yini position it depende kuphi ngapha ku independent variable. So the dependent it depend on the change isayenzekayo ngapha kulo kanje ku independent variable. So position changes over time. So time, that means independent variable. Now 3.3, but use the information and the table above and draw an accurate position time graph on the graph paper on the attached answer sheet. So now graph sheet there together, right? So on the x-axis uzothola your time. This is where your independent variable kwamele ihlale khona, on the x-axis. On the y-axis kwamele kube dependent variable yakho ke. Now but is plot again for 0 seconds, lana it's 0. For 0 seconds ngina 0 position. So it means that lana at the origin is in a point 1 and 5, 1 and 5. Now 1 and 5, and then kuba nobani 2 and 10, 2 and 10, 3 and 15, 3 no 15, and then kuba 4 no 20, 4 as well as 20. This is the point. Now then you are connector ke lama points uba ne straight line graph la. Here we go. So ucedile ke kanjalo. For how many marks? 5 marks. 3 marks. 3 marks. Now so 3.4, but is calculated the gradient of the graph. So for the gradient you can choose, you need to choose 2 points. And so the gradient is calculated as, the gradient is equal to changes in y over the change in x. What's the change in y? You need to choose 2 points. So let's say ngithatha this one, maybe this one, this point, maybe not this point, it doesn't matter. When you tata this one and this one, you should get the same answer. So let's call this point 1 and this one point 2. So kuba y2 minus y1 over x2 minus x1 equal to, what is y2? y2 10 minus y1 15 divided by x2 2 minus x1 3. So what is 10 minus 15? Negative 5 divided by 2 minus 3, it's minus 1. So our answer is 5 meters per second. By the way, the gradient for a position versus time graph, the gradient for a position versus time graph gives us velocity. And in a position versus time graph, velocity versus time graph, sithola what? Sithola acceleration when we calculate the gradient for that graph. So 3.4, this is the gradient. It means that le moto lebe by investigator lapha, it was traveling at 5 meters per second, the speed sakhona. 3.5, okay, la ngizoshaya space, but anyway ngizo squeeze in somewhere la. 3.5, draw not to scale a corresponding velocity time graph for the motion of the car. So now 3.5 asumenze la, now 3.5, and then lana sinesikhathi, and then lana sine velocity. Now thatha ukubheka, a straight line has a constant gradient. Ngathini? On a straight line equation there's a constant gradient. So nalana the velocity the velocity time graph, the corresponding velocity time graph is over just a straight line, ngoba the gradient is constant la ku position time graph yethu, which is what? It's 5 meters per second. So the velocity lana is what? It's 5 and it's constant again. Remember, it's constant. Now 3.6, but hence deduce the magnitude of the acceleration of the car. The acceleration is over equal to 0 meter per second squared. The acceleration is 0 because of the velocity. It's what? It's constant. In a constant velocity there is no acceleration, right? So answer to 3.6, it's a straight 0 la. It's a straight up 0 ngoba velocity to injani is constant. So yeah, question 3 phelela lana. I hope uthole some value out of this video yanamuhla. So nangabe uthole some value, please leave a like, share and subscribe. In the description box uzothola ama links for other recordings. So for now, asibonane on the next video. Bye bye.